Hello guys, welcome back to the channel again. Today we will solve the 29th question of June Leetcode challenge. So our question is unique paths. So what we have to do, we have given a M cross N grid and we have to go from top left corner to bottom right corner, and we have to find out the unique paths in which we can go from start to finish. Now we can only use two type of paths. We can either go to right or either go to bottom. So we have to find out the path or number of paths possible while going from start to finish. So suppose we will take the example of 3 cross 2. So we will consider the example where m is equals to 3 and n equals to 2. So for m equals to 3 and n equals to 2, our matrix or our array will be this. So we have to go from here to here. So for our first path will be this, second path will be this, and third path will be this. So if we want to reach here, we require 3 paths, or we can go via 3 paths. So this is how we have to find out the number of unique paths while you can go from start to end by using only two types of moves, either right or down. Now for understanding the question, we will take this as an example where m will equals to 3 and n will be equals to 3. So we have to count the number of paths to go from top left corner to bottom right corner. So we have to count something. So for counting the number of possible paths, the only thing which we use is dynamic programming. So in this also we will use dynamic programming only. So we have to traverse into a 2D matrix, so we will use a 2D dynamic programming. So in this, first of all, I will create a DP 2D matrix and initialize all its value by 0, and I'll initialize all its value by 0. So after initializing, the values will be something like this. So what DP will store, or what index of DP will store which value? So first of all, this 0th index will store 1, because we all know that in DP, first of all, we have to declare something. So in this also we will declare this 1. Now how this 1 came? Because the number of possible paths to go from 0, 0 to 0, 0 is only 1. Now after that, what I'll do, I'll try to find out paths of every path. Now if I reach up to here, suppose there are only one possible path from going here to here, so we'll add this one. Similarly in this also it is 1 only, till here also it is 1, till here also it is 1. Now in this, at this index, I can go from 2 paths. So how I will find these 2 paths? I will add these both and I will add this into this answer, so it will be 2. Similarly I'll do for this also. I will add these both 1 and 2, so here value will be 3. Now here again we will do the same thing, 2 plus 1, so it will be 3. Again we will do the same thing, so it will be 6. So now what these elements represent, this one represents the number of moves required to go from 0, 0 to 0, 0. This represents from 0, 0 to 0, 1. This represents 0, 0 to 0, 2. What this represents, this 6 represent is the number of possible paths from 0, 0, 0 to 3, 3 or 2, 2. So this is our matrix which we will form using DP's logic. Now how we will implement this using the code, we will see our code and then we will submit our solution. So that this is the code for our solution. So first of all, I have initialized, or I have declared this dynamic programming array. After this I have initialized first index, So after this the main code comes, so in which first of all I have iterated over all the values and then added their sums according to that. So first of all we will look at the variables, that how we will initialize all the variables. So first of all I have initialized this dp. So dp's all values will be initialized with 0 initially. So dp will initially look like this, but after this second line this 1 will be there. Now two more variables we have created, I and j. So I will be initially 0 and j will be 0. So for 0 comma 0 this both condition becomes false, so we will not do anything. Now I will become 1 and j will be as it is. Sorry, before it becomes 1 j will be incremented first to 1. Now for 0 comma 1 this condition will be false because it is equals to 0. Now what will happen, I'll add its j minus 1 index, means this index will be added with this index. So this both index will be added and sum up here. After that j will again be incremented to 2. Again same thing will happen, 1 will come here. Now here 1 will be there, here 0 will be there. After that what happens, I will be checked that if I is greater than 0 or not. So in this condition becomes true, so it will be 1 because we will sum up with this. Now our second condition will be false because j is not greater than 0. After this I'll increment this also by 1, and these both values will be added by this. First value will be upgraded to 1 first in first loop, in first condition, and after second condition this value will become 2. Again we will come on this condition, same, this will be incremented first to 2 then to 3. Now you must know that till here j will be 2. Now after that I becomes 2, j will be 0. So again this value will be upgraded to 1, then j becomes 1 and this value will be upgraded to 3. Now j will become 2 and this value will be upgraded. So 3 comma 3, 3 will be there. Sorry, 3 plus 3, 3, and then after that one more 3 will be there, so it will be 6. So our answer, what we will return, we will return its last index, which will be dp's m minus 1 and dp's n minus 1. So our answer will be this. So in this case our answer will be 6. So this is a simple solution for this question, and this is a pretty standard dynamic programming question in which we have to add all the values till the end and the last value will be our answer. So we will submit this question. So now if I submit the solution, I got correct answer, and if I see more details, it is faster than 100% submissions, and its time complexity or time usage, or memory usage is also very less. It is greater than 80%, so it is very efficient. So this is my simple approach for solving this question. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.